Hi everybody. Today we're going to look at cops in Houdini, and I'm really excited about cops. It's one of those tools that you kind of wish for forever, and it comes out and it's kind of confusing and it's kind of scary, but it's very exciting. My main texturing tool is Substance Painter, and I really like Substance Painter. But it does have some things, some limitations that I've been kind of fighting with and working with for forever. And when Cops came out, I was like, this is amazing. So I wanted to start this dev blog. So hopefully I'm going to do a couple of these on converting some of my favorite features of Substance Painter into Houdini Cops. There will be some downfalls. I probably won't be able to get a one-to-one functionality, but I think I can get close. And so what I'm going to do today is we're going to look at what I want to accomplish, the tool in Substance Painter that I want to replicate, and a quick walkthrough of how I did it. Now, this isn't going to be a step-by-step tutorial. Maybe I'll bring, if there's enough interest, I'll do a like press this, press that, press this. But moreover, I want if you get nothing out of this, I want you to start thinking not in images or geometry. I want you to start thinking in data, because once you start thinking in data, you can do a lot. You're not reliant on any particular application. If the application you're working in gives you access to that data, which Houdini does. That's what Houdini is notoriously amazing for, and notoriously scary about, is that you have to know how the data works. So hopefully this can get you started in Cops or even Houdini if you're so inclined. So the first thing I want to do, I wanted to replicate two features in Substance Painter that I use all the time, which is planar projection and warp projection. So what is this? So if I just go to any of my, let's just go and grab any of my alphas. Let's go to this guy here, right? So I have my stack here. So I'm just going to drag any one of these up onto my current mesh and let go. And it's going to ask if I want this to be, so by default, it's going to make it a mask. So we can see where this is. I'm just going to make this red. So by default, when I drag something on and make this a mask, it sets it to warp projection. So we can see this happening here. So there's two types of kind of like planar-esque projection in Substance. There's warp, and then there's just straight planar. And if I change between the two of these, there's triplanar, there's planar. They look pretty much the same, because until you start moving around the vertices of warp projection, it's pretty much just a planar projection, which is pretty cool. So I can leave this at warp projection here. The other thing that I wanted to try to replicate, which I'm close but I'm not quite there yet, is this surface tool, right? So as I drag this around, the object sticks to the surface. Now, this is planar projection. Now, what's the difference between planar projection and warp projection? So if I drag this over here, we can see, and I keep it the same size, I can rotate this in 3D space. We can see that we have like these points here. Now, this is actually a piece of geometry. So what's happening is this piece of geometry has a UV coordinate on it. So there's a U direction here, U, and there's a V direction here. And what's happening is I'm basically texturing this kind of phantom piece of geometry, and then that data is being, once again, thinking of data, is being transferred onto these UVs. Okay, so with that, with the warp projection, what I can do now is I can manipulate this piece of geometry to wrap it or warp it around my mesh. So I can come in here, I can do edit vertices, and I can start to grab these vertices, and you can see as I move them, they're going to start to ratchet down to the surface. So I can give our little meat mat here a little arm tattoo, something like that. So I can wrap this around. I could also use cylindrical projection, but we'll get to that later. So that's the main kind of idea that I want to recreate in Cops. So if I go over to Cops, I have a setup that's kind of like this. So if as I'm looking at my cop net over here, I'm displaying that because that's putting out my texture geometry. And so how this works is if I go into my transformation tool, I have this plane here. So remember that over in Substance Painter, like that plane was an implicit piece of geometry. I'm willing to bet it's like a NURB surface, it's a Bezier surface, but I'm using geometry, or not geometry, I'm using polygons here, which is fine. Like geometry is geometry, right? So as I move this around, and let's go back to my CopNet. As I move this around, that geometry is projecting to my surface. Now there is I've built in a distance parameter in here, and I'll show you what that is. But this is where I wanted to go, or something like that. So if I'm on this transformation tool, the one thing that I haven't gotten to work yet, which we might get to in this lesson, or maybe not, is the surface connection. So if I wanted that to work, I'd probably have to make this an HDA and maybe use like some Python states, but that's future development. But what I can do is I can tap my semicolon and I can click on any one of these faces or points or edges, and it'll align my mesh to that part. So tap semicolon, I want this here, tap semicolon, I want that there. Okay, so let's go back to this relatively flat spot. So how does this work? So I have my target geometry over here. So I started with just the pig head, and on my pig head, you can leave add shader on or turn it off. It doesn't really matter. And I'm just to get a little bit more fidelity, I'm just subdividing that. And then this, I'm saying out pig, and that's going to go into my CopNet, and I'll show you where that is here in a minute. Now, for my projection, I'm just using a regular plane here, just a square plane, because UVs are generally always square. I'm doing a normal. I didn't know if I needed those or not. I don't think I do. I might. I don't know. But generally, it's good to have normals coming into your geometry. You can use normals for all sorts of fun things. And then I do a UV project, and I just went to my UV project and pressed initialize to get nice square UVs in here. And then I transform it into space. So if let's see, frame this up. So this is where this thing is in space, and I just manually move this around. An optional thing that I have going on here is I'm running array against my geometry. So this is kind of like the warp, quote unquote, warp part of warp projection. So just like in Substance, if I don't warp my warp projection, it's just a plain air projection. So if I have the switch node here, so I can switch that over, and you can see that that'll ratchet down to the surface of the pick. So that's the geometry setup. Now, if we jump into Copernicus here, if I go back to viewing my Copernicus, so this is the main setup. It's not super complicated. The main part of it that makes kind of everything work is this Wrangle here. And when we get to that in the network, I will show you and explain what that is doing. So the first thing I do is here, I'm just doing a SOP import, and I'm grabbing my little pig head. And in the second SOP import, I'm grabbing my my patch here. So if I look at my patch, oh, actually these are nulls, because I'm planning on turning this into an HDA. So this is kind of the process, the first process I take when thinking about HDAs. I think about what my inputs are going to be and what my outputs are going to be, and I make those nulls. You can even see I have user input. So here is where my out pig is coming in. So that's the pig, and this is my patch that's coming in. And even so, let's just do this. Let's say pig here, and we'll say patch, so we don't forget which one's which. So these are coming in, and these are coming into null. So these are just kind of like pass-throughs. Okay, so let's look at our pig first. So the thing that really confused me, not really confused me, but that took me a little bit of time to get my head wrapped around, is this rasterize setup. Like, I didn't understand what this was doing for a fair bit until I started getting into the system. So what's happening here is Cops is pretty amazing in the way that you have direct access to geometry and textures. Because in Houdini, this is kind of something to wrap your head around. In Houdini, especially in Cops, images are fields. They're height fields. They're actually geometry that is floating around in space. And all these operations that you're doing on quote unquote imagery you're working on these height fields. And once you understand that, a lot of the kind of like the weirdness kind of goes away about Cops if you start thinking in data. So if I go from my in geometry to my Rasterize setup, you see what happens here. So these are still polygons by any means. These are definitely still polygons. What this is doing is it's taking the UV data, right? So on my Rasterize setup, and this is one thing that gets me all the time, the Rasterize setup by default comes in as position. And like when you plug it in, you're like, what is this doing? If you're using position, it's just taking the world position. of your geometry. If you take the UVs, it's pulling the UVs in still as geometry, but it's splitting up your UVs and it's flattening out your model and it's putting it into a -1 to 1 space. So if we look here, this is the far corner down here is -1 and the upper corner up here is 1. So it's -1 to 1. So, and I think they did this. I think the logic behind this is that generally UV maps go from 0 to 1. So that would be over here or something like that. And that would just be weird for the user to not be kind of centered in world space. So I think they did, but they didn't want it to be 0.5 by 0.5 by 0.5. That's weird, or 0.25 by 0.25. So I think they just made it 1 to 1. It's just easier to do math that way. So I think that's the logic behind it. I'm not 100% sure. So what this Rasterize setup is doing is it's taking your geometry and it's flattening everything out. So what it's also doing is it's grabbing the depth. So this doesn't have any depth. So this is just going to be 0. And then it's also grabbing this origP. And this is very, very important. So this confused me because I'm used to using Houdini in the SOP context. And I always use @p to get my world point positions. That doesn't apply here. If I want to use the @p of my original geometry, and I've converted my original geometry into this, like that @p becomes my UV space. This is 0 to 1 space. So that really, really confused me because I was like, I'm using @p, but I'm getting like these wacky values because when you use @p after this rasterize setup, you're using this p here. Like this 0 to 1 p, not the p, the position of your original mesh. So that really, really confused me. So I really wanted to kind of like drive that home in this video. So that's where this origP comes in. So this rasterized setup, what it does is it takes your original point positions and it stores them in this origP. So I can work on this flattened, quote unquote, to be rasterized, or after I rasterize it, setup, whilst referring my original position. So it's a little bit of mental gymnastics, but it's, once you get used to it, it's just like anything, it becomes a little bit second nature. And haven't been working with this that long, so it's still not second nature for me. So the other part of these reasons for these videos is just to document my process, because I'll figure something out and I'll leave and I won't touch it for a while and I'll come back and I'll be like, what was I doing? So I'm just using this as kind of like a diary, and hopefully it helps you out too. Okay, now let's break down this word rasterize setup, or rasterize, whatever, right? So there are two types in computer graphics land, there are basically two types or there's many types of information, but the big two types of imaging information, or even geometry information, are raster and vector. So what raster geometry is there's information everywhere. So you can think of, if you've ever done smoke simulation or volume simulations, that's raster geometry. There's information everywhere. There's attributes everywhere. Even there's no such thing as an empty voxel. There's a voxel with a value of 0, like if you have density or an SDF model, you can have a density of 0 or an SDF value of +1 or -1 or 0, but there's still information there. Raster setups are quite expensive because you have to hold information everywhere. The other thing that could also be along these lines considered a raster setup is any image that you ever worked with. Because what is an image? An image is a field, right? It's rows and columns of pixels. A pixel is the smallest element of an image, right? It has color in it. Now, even if you have a white pixel, there's still data in there. There's red of 1, green of 1, blue of 1. There's still information there. Now, if we look at vector geometry, that is any traditional 3D model that you've used. There's only information where the math dictates. So you only have information on points. You only have information on faces. You only have information on edges, and so on and so forth. If we were to go to a 2D context, this would be something more like Illustrator. This is why Illustrator files are so light, because they are vector images. In that image, it may be showing you white on your screen, but unless there's a path or a fill or something there's no information there, right? So when we're going from geometry to texture land, we need to change our vector information into raster information. So we need it to change from something that is sparse and only works on geometry to something that has lots of samples that we can add and blur and all that stuff. That is what the rasterize geometry node does. So by default, so this really, I was like, why do you need these 3 nodes? So this kind of explains it. And I haven't really seen very many people, like, they show you the setup, but they're like, look, put this, put this, put this. But like, I was like, why are you doing this? So I'm trying to explain why I'm doing this. And this video may get a little rambly because anytime you have to bring in kind of like deep theory and things like that, or not deep theory, but like core theory, it does take a little bit. So I could do a rasterized geometry by default. And I'll pull this into here and pull in my geometry. If I look at this, now I get an image. Now this is a solid image. You can see here that there are gaps in this. There's no information in these gaps because this is still technically geometry that's just been flattened down to a flat plane. What this is doing is it's actually taking that geometry and it's turning it into, taking that vector geometry and it's turning it into an image or a height field or raster geometry or whatever you want to call it. So we have these quick setups here. So what I can do is I can grab my UV data. So now down here, this says intrinsic alpha, I'm gonna say UV data. So this is now my UV data for my pig. And you can see down here, like the closest thing that we can get, the first bit of geometry the first bit of information we get is very red. So it's very red along this line, and it's very red along this line. And then it becomes yellow up here because red and green together at full value gives you yellow. So that's pretty basic, and there are some problems with this. I'll link some tutorials by Rohan Dalvi, who is an amazing instructor inside the mine. It's great, great channel for all of this stuff. Who else is good for this? Matt Estes, I think he actually works for geometry, and 9 Between, and then CG Wiki. Those are like kind of like my those five resources are kind of like my Houdini Bible whenever I'm stuck or something and I need to go get something. So definitely go check out those creators because they've helped me like more than I can even imagine. So what I'm basically doing now is I'm pulling that data off of the geometry, off of the vector geometry, and I'm turning it into a raster geometry. Now, here's what confused me is if I grab and I do, this says at P, and I come down here and I say, I look at P, this looks wrong because it is wrong. Because remember, this at P is not the positions of my original geometry. This at P is this position here. And you can see how my at P and my UV look very, very similar, except for this dark patch down here, right? Because at P is, it's world space. So all these values down here are below 1. So this is negative X and this is negative Y. So these are all black. There's data there, but you can't see it, right? Because anything below 0, computers just spit out as black. Just like anything above 1, computers just spit out as white, right? This is kind of like high dynamic range imagery. That's the other great thing that working in Houdini, I feel like, is an advantage over Substance Painter, is Substance Painter is locked to images. Houdini is not generating images. Houdini is generating data, which is then later, when you export, turned into images. So this is 32-bit float most of the time, or at least 16-bit. Don't quote me on that, but it is data. And the fact that there's data down here, but we can't see it, proves that, which is fantastic. The most Substance Painter can do is it can go from -1 to 1, and it usually does that for height maps and whatnot. So that's a big, big advantage that you get for all kind of this rigmarole where you have to kind of build stuff yourself. That's the advantage. Okay, so let's go now to this first wrangle. So what this first wrangle is actually doing is it's replacing the rasterize geometry. For reasons, I'm not really sure why. When you rasterize your geometry, so if I come back in here and I use this rasterize geo, and let's just grab a position or our UV. So if we look at our UV here, and we visualize this, the UV, like I don't know why this is like this, but it stops at this edge. And if your data stops at the edge and it just becomes black, this will introduce seams in your textures, because this color, wherever this matches up, won't exactly match the color that's coming in. There'll always be a little bit of black in there, and that's from anti-aliasing. That's not. That's from having textures that are really small. So the first kind of hurdle is to fix that. And I didn't come up with this myself. I got this from Inside the Mind, and I believe Rohan Dawi, and I also think Nine Between kind of go over what this is doing. And this is what I talk about when I talk about Houdini works in data. Like, it's always data. So if we look at this Wrangle here, in here, what I'm doing is I'm bringing my input 1, which is my Rasterize setup. So this is, remember, this is my geometry. I'm bringing in geometry here. And then I'm bringing in this origP, and I have this layer. I don't even think I need this layer now that I think about it. I don't need that layer. So just one node. And so you have this little bit of code here. Now, don't run. Like, I know that people are like, oh, code, I'm an artist. It's not super difficult. It is a little bit difficult. I hate it when instructors are like, oh, it's so easy. It's like, no, it's not easy. That's why I'm coming to you for help. So it is a little hard to understand. And if you're uncomfortable, that's okay. Like, discomfort is part of learning. So this is what I'm going to do. I'll walk through this step by step, and hopefully I'll be able to draw this out and allow you to kind of wrap your head around what's going on. So the first thing I'm doing is I'm making an integer value. So an integer value is 1, 2, 3, 4, nothing in between. So I'm calling this primitive. Now, why am I calling this primitive or prim? So once again, everything in computer graphics is data. Every single face has a number to it. Every single face on your model. If you have a model that is 20 million polygons, like if you're coming out of ZBrush or even sculpting in Blender or something like that, every single one of those faces, there's a face from 0 to face 20 million. Every single one of those has a number. Otherwise, the computer couldn't sort it. That's how it holds that data. It holds that information as an integer. You can't have a fifth of a face, or you can't have a half of a face. It's either on or it's off. So that's why it's an integer value. It's face 1, face 2, face 3. So the next thing I'm making is this vector called UV. Now, vector, the word vector, I know strikes fear into many upcoming artists, right? A vector is just 3 numbers packed together, right? So a vector is just 3 numbers. So we could think of X, Y, and Z. So that would be position. We could think of this as R, G, and B. And we would think of that as CD or color, right? But there's bunches of other types of vectors. We could think of direction as a vector. It's something that's pointing some way. We can think of velocity as a vector, also something pointing some direction, right? So why you've been talking here, you might be thinking like, Brian, you've been talking about UVs in 2 dimensions. So U and V. Deep down in every single computer graphics software, there is another vector, there is another axis in your UV. It's called W. So if you think about it, like, this would be your UV map of whatever you've unfolded, and there's this W aspect to it. We normally don't use this. In most software packages, in Maya, in Blender, in any other package, that third dimension, that W dimension, is just ignored. Houdini doesn't do that. It was like, okay, it's in there. You might need to use this for something, so we're gonna give you access to that. So that's why I'm making it. It's a vector. It's a vector. So this could technically be called UVW instead of just UV, but all the documentation just says UV, so I'm just sticking with the documentation. Okay, that basis, number theory, out of the way. Now, what's this crazy attribute here? What is this doing? Okay, so first thing, this is just a bucket. It's a variable. It's a bucket for information. So what is a float? A float is just a single decimal point value. So it could be 1.1, 2.2, a million, 0.5, 3 point, whatever, right? So this gives you more data between your integers. That's basically what a float is. And basically what this float, I want to represent the distance to the surface. Now, I don't use this, but I usually write my functions always the same, just so I don't have to memorize everything. So this is a distance. This is a distance, right? 4 meters, 2 meters, 0.0001 millimeters, whatever. Now, this is the hard part, right? X, Y, Z dist. And this is why I went through all that trouble to explain what's going on in this prim, in this int up here. So what X, Y, Z dist, what it's doing is, let's say I have a piece of geometry that's something like this, right? So I have point 0 through in, and then I have prim 0 through in, as in however many primitives I have. So what this is doing is this 1 is that geometry. So that 1 is the geometry that I'm pulling in. What geometry is that? That is this rasterized setup. I'm pulling this geometry into this wrangle. Okay, so that's 1 because input 1, 1 here. Now, next, what is P? This at P. At P is, remember, at P is this from here to here, and from here to here, and from here to here, where that is sitting on the surface, right? So here I'm using this position, the positions of this rasterized setup to bring this into here. So I'm taking my first input, which is this geometry, this rasterized setup geometry. I'm grabbing its position, that 0 to 1 position. And then I'm saying, basically what I'm saying is give me the closest primitive number, right? So this is an int. So it's basically filling in this for me. It's saying, oh, I'm next to, let's say, for example, I had a point that was like right here. So basically what this is doing is it's saying, okay, this is my at P, that's my point in space. And then it's saying, what primitive am I closest to? So this one, in this case, this would be primitive 0. If I was here, like if my at P was here, my closest primitive would be here. Like, so primitive 1 and so on and so forth, right? So that's what that's giving me. So this is going to be whatever it finds here, that's going to be primnum. And then there's this UV value. Now, this, when I first started doing this confused me to no end. I was like, what? Like, I didn't make any UVs. This doesn't have any UVs on it. This UV is not a user, as I like to call it, a user-based UV, right? In the traditional like way where you make a model and you unwrap it and you have your UV space and then you texture your model based on the UV space. These are what I like to call parametric UVs. So for any face, so let's say you get like this is prim now. This is what I'm looking at, this prim. Let's say this is prim 45, something like that. Any number, right? Within this prim, like on this face, there is a tiny UV map, an intrinsic UV map to this. You don't have to build this. It's just part of the geometry. That it's getting this UV is getting this information like here or here or here or here. It's basically like sub face information is what you're grabbing. So because I have these 2 bits of information, I can grab information off of this face, right? So I can grab the position wherever this point is. I can grab its position. I can grab whatever UVs are there. I can grab whatever normals are there. I can grab any attribute that is on this geometry. I can snag using this information. So this xyzdist just fetches kind of like this location information for me. You can think about it when you have to go somewhere. Let's say you have to go somewhere to pick something up, right? You have to go pick up a package from a store. What do? You look up the directions first, right? So you can think of the store as the prim, and the thing that you're picking up is the package, right? Or is the data that you're picking up. Once again, always thinking in data. Okay, so the next to pick up that package is this function called prim UV. So you can see prim UV once again is using this one nomenclature, and that is our geometry here. And then it's saying, what do I want to get? What do I want to pick up from that store? What do I want to pick up from that location? I'm going to the stationery store. I need to get some super glue. So this is what I'm going to pick up, this attribute. Remember, this attribute, origP, is my original point in space, okay? That's very important because I'm going to use that over and over again, but I'm not going to use it from space. I'm basically taking that information and I'm turning it into a height field, which I will then export as an image later. It's very important, okay? And it's like, okay, where am I going to pick this up? I'm going to pick it up from this primitive at this UV spot that I filled in here. So these 2 functions happen together. They work in tandem a lot. Okay. So now, my result here is my origP at this prim at this UV location, right? And so now I can take my origP and I can just spit that out as a result. How do I spit that out? So down here is where I can define my inputs and outputs. So here I'm making a type RGB. This is a vector type. right? Because I want my position in space is XYZ. Once again, everything is data. RGB, XYZ doesn't matter. They're just numbers. What differentiates them is how the software takes that information and displays it back to you. That's really it. And that is beautiful. This is what I love about Houdini. It doesn't hide anything from you. But by doing that, it's a little bit harder to use because you have to know these base principles, or else you're just kind of like clicking buttons and hoping for the best. So the reason I do this is you can see the difference. So if I look at my origP here, so this is my origP, and let's just drop down a rasterize setup or rasterize geometry. So if I look at the difference between these two, let's grab P position. Now remember, this is origP, not P, right? So I'm going to come in here instead of P, which is this geometry's position. I want to grab the origP from here. So I'm going to Control C, and I'll come down here and I'll do Control V. And we can see that these two colors are very similar. They should be exactly the same if the math is correct. And I do believe that they're exactly the same. I could prove this. Let's just do a subtract. And because anything minus itself is 0. So if I take this and I take this, plug this in, yeah, there we go. So here is where these values are overlapping. They're exactly the same, right? So if this is the same as this, at this point, it'll go to black. So all this stuff is going to black. The difference between the two is we don't have these black islands between. This kind of bleeds out, and that helps us with our filtering and make sure we don't have any seams. Okay. So let's close that down. And I think I'm going to stop this here because I've been talking for I've been talking for a while. So I'm going to stop this here because this is going to get super long at some point. And we'll pick up with the rest of the setup in the next video. So I hope you got something out of this. Even if you just watch this, if you get nothing else out of this, just remember everything is data. Think in data, work in data, and you'll be good in Houdini. So I hope you enjoyed this, and I hope you come back to the next one because this is really fun. If you can't tell, I'm super excited about this, and it's only going to get better. So yeah, so have a good day, and I'll see you in the next one.